Hello, everybody. Um, with this presentation, right, we really just have about maybe 6 or 7 slides left in covering the digestive system. If you recall, right, last presentation, that's where we really kind of spent the bulk of the presentation on looking at the portion of the GI tract from the stomach and all of the digestive contributions of the stomach from the secretion of gastrin, being the hormone, which stimulates the various digestive enzymes from the pancreas and so on and so forth. We made our way through the large intestine and kind of all of the functions of the small and large intestine. Now, today we're going to just, like I mentioned, just kind of finish up the last half a dozen or so slides. And here's where we're going to start to look at kind of what regulates these different processes, right? For instance, we have to make sure that the secretion coincides with the bolus or with the chyme or with the food or with the stool, right? We don't want chyme, right? If you'll recall last presentation, last class, looking at the movement of the chyme, right? That acidic slurry of food from the stomach, how that moved through the pyloric sphincter and entered into the duodenum. The duodenum that's the first part of the small intestine. It's very delicate, sensitive tissue. So we had to somehow counteract or make sure that the acidity of that chyme wasn't going to damage or destroy the inner lining of the duodenum. So there was a secretion from the pancreas as well as from the gallbladder, being sodium bicarbonate, which helped to neutralize the acid. Well, we have to make sure that the movement of that chyme coincides with the secretion of that bicarbonate, or vice versa. We have to make sure that that bicarbonate is secreted in enough time to actually protect the duodenum. So we can see there's two groups, right? Kind of two different portions of the nervous system. Now, beginning of the semester, right, we talked about the nervous system, right? We talked about it, for quite a number of weeks. Something called the enteric nervous system. That's the portion of the nervous system which regulates the GI tract. Right, we're going to see a chart here in a minute, but the enteric nervous system is able to function independent of its own, or independent, right? That's not to say, right? Don't confuse that with, oh, well, the central nervous system can't impact the GI tract. Not at all, right? The central nervous system can and does absolutely 100% impact the GI tract. However, the enteric nervous system is able to function independently on its own, doesn't need the input from the central nervous system. And there's two, again, plexi, or two groups of nerves, which essentially kind of cause that to happen. So again, why is it important to highly regulate the movement of the food through the GI tract? Well, as I mentioned, if food's in the mouth, we want to make sure that saliva is secreted. As food's traveling through the esophagus, we need to make sure that mucus is secreted. As food is in the stomach, while the stomach twists and churns and moves, we have to make sure that all the gastric juices, from hydrochloric acid to pepsinogen, for instance, we have to make sure they're all secreted. All right. So when we look at these things, sorry. There we go. All right. So when we look at these, right here, we have the submucosal plexus, or the plexus of Meissner. This is, whatever you want to call it. But all this yellow nerve supply, right? All of that yellow nerve supply, when we look, that goes down to the submucosa. We had in through here, right? This kind of whitish. I'm not sure what happened with that one, but this whitish part in through here, that's the submucosa. You can see there's a huge number of glands in the submucosa. Right? So one of the responsibilities of this submucosal plexus is to regulate the secretion from these glands. Now, The same token, the myenteric plexus, myo, muscle. All right, so all of this muscularis layer, all this in through here, this is what's going to actually move the food along the GI tract, right? This is what actually propels the food from the pharynx, from the esophagus. The esophagus undergoes peristalsis. Peristalsis then essentially pushes that food down into the stomach. It's the myenteric plexus, or the plexus of Auerbach, which actually regulates this movement of the food. Right? It's the myenteric plexus which regulates the movement of the food, right? Or the movement of the stool or the chyme, whatever it happens to be. So they both have to coincide, right? We have to ensure that the food, or the let's just call it food, right? The food that you've swallowed, we have to make sure that it doesn't move through an area before the mucus or before the enzyme is secreted. That would make no sense, right? But one of the things that we can ensure, because of the submucosal and because of the myenteric plexus, is that as the food moves through, that the various glands in the submucosa secrete that secretion of mucus, or hydrochloric acid, or whatever it happens to be. So these are the actual kind of mechanisms that control both plexi. And you can see how one of the things, when I mentioned, the central nervous system absolutely 100% can impact the enteric nervous system. And it does. However, right, if we just look through here, right, emotional states, right, smell of food, sight of food, taste of food, all of that can stimulate the enteric nervous system. Absolutely. That was a horrible arrow. But even if we erased all this, I got rid of this, through these short reflex pathways here, that still stimulates the enteric nervous system. Right, when I mentioned, right, distension of the stomach, distension of the duodenum causes the release of various enzymes. Yeah, that's the short reflex pathway. That's where, it can function independent to that of the central nervous system. Right. This is why, people, even post-mortem, upon death, right, your digestive system actually continues to function for a brief period of time, right? Even though the central nervous system is dead, right, there's no activity in the brain. Well, even though there's no activity in the brain, the enteric nervous system can still function independent to that, and it does. That's why for a brief period of time following death, your enteric nervous system, your GI tract, continues to actually function. So as we age, right, aging with as far as in regards to digestion, we can see a couple of things. One, decreased secretory mechanisms and motility. Yeah, a big part of how much we secrete, right? How much digestive enzymes the pancreas secretes. How much gastrin does the stomach secrete? All of that is based upon essentially the sensitivity of stretch receptors. Right? Remember, I had mentioned how it's distension of the stomach which causes the release of gastrin. Well, the reason we can measure how much the stomach stretches is because we are able to detect how much the stomach stretches through these stretch receptors. Same idea with the duodenum. As the duodenum, remember that first part of the small intestine, as the duodenum fills up with chyme, it distends. Upon that distension, that stimulates the release of bicarbonate as well as the release of digestive enzymes from the pancreas. Well, these stretch receptors right, just think about it. By the time you've turned 50, 60, 70 years of age, these stretch receptors have stretched tens of hundreds of thousands of times. So yeah, just like a rubber band, it's elastic. You stretch it. You can't stretch it a million times. It'll break. As you stretch it more and more so, over time it wears out. Same exact thing inside of the body, right? Tissues wear down as we age, right? I'm not that old. I walk up the other day, I lay down on the floor to play with my kids. And 5 years ago, I didn't have this much difficulty getting up off the damn floor. Same thing going up a flight of stairs. I'm like, geez, I don't remember this being this hard. Right? So as we age, tissues don't repair as well. Right? Tissue synthesis doesn't occur as readily. Right? Damage to ligaments, tendons, joints, etc. Right? They limit flexibility. They limit the mobility of certain joints. Same idea within the GI tract. We see loss of strength, tone of digestive muscular tissue. Yeah, same thing as we age. There's this loss in tissue strength. Right? Changes in neurosecretory feedback. That coincides with the decreased secretory mechanisms. Right? The neurosecretory feedback, one, we're secreting less enzyme, but two, the sensitivity to these different hormones, to these different secretions, to these different enzymes, that also decreases. And then diminished response to pain and internal sensation. Same exact idea, right? Just as the same as these stretch receptors over time wear out, right? Same exact thing. These internal sensations, there are little detectors or receptors to all of these different sensations. And over time, these receptors or these detectors wear out. All right, so because of after 20, 30, after 30, 40, 50, 60 years of functioning, these receptors no longer have the sensitivity that they once did. So therefore, if they don't have the sensitivity for which they once did, they no longer secrete as much hormone, they no longer release as much enzyme, and so on. Now, these are just some of the issues, kind of some of the more, some of the more common, some of the more, some of the more common, issues we might see in the GI tract. We see diverticula. Right. With diverticula, right, one of the things, diverticula in and of themselves are not terribly problematic. Right? Diverticula aren't painful. They're just kind of outpouching throughout the colon. Now, if you have diverticula, that's called diverticulosis. Again, diverticulosis, that's not problematic in and of itself. Right? That's not painful. When they become inflamed, irritated, painful, that's when it's called something called diverticulitis. Right? Because of the diverticulitis, if you have diverticula, right, one of the things that that is generally recommended that you don't consume are things like seeds, right? Small seeds, nuts, things like that, things which can get kind of caught or trapped in the diverticula. When they get caught in the diverticula, that's where they can then get inflamed and irritated. Right? So diverticula, that in and of itself, again, that's not so much painful. It's when they become inflamed, that's when diverticulitis occurs. That's when it's painful. Hemorrhoids, again, just simply, dilation of the anal veins, right? The veins lining the inside of the anal canal, right? Generally, it's, straining, right, through a bowel movement. That's generally what's going to cause them to enlarge and engorge. Right? It takes a huge amount of pressure in order for defecation to occur. When that pressure becomes, again, significant because someone's constipated, that can cause the actual veins themselves to engorge, and now we have hemorrhoids. Now, with hemorrhoids, let's say if you have a bleeding hemorrhoid, right? It produces frank red blood, just like red, bright red blood. The same, it looks just like what you would think. You cut your finger, right? It looks like that, right? That's much different than something called melena, right? Melena is this kind of blackened, darkish, tarry stool, right? That's one of the ways you can kind of differentiate where certain bleeds are coming from. Like, oh, okay, We know so-and-so Jane Smith has a GI bleed. Oh, where is it? I don't know. All right, well, there's blood in her stool. What's it look like? Ah, it's bright red. Okay, most likely it's a hemorrhoid, right? It is some distal aspect the of the GI tract, right? Something towards the very end. The reason why I say it's towards the very end is because if there's a GI bleed, right, earlier on in the GI tract, what happens is the hemoglobin portion of the blood actually starts to get broken down as well as certain portions get reabsorbed. That's what then gives the stool this kind of blackened tarry appearance. That's what's called melena. So let's say if somebody a chronic NSAID user, right, GI a small right GI bleed. If there are individuals who literally for arthritis and things like that, they might take ibuprofen every 4 hours around the clock, right? And it's very common for them to develop GI bleeds, right? Small GI bleeds, especially in the stomach. So when this happens over time, that causes, again, melena because of the fact that GI bleeds occurring in the upper portion of the GI tract. So enough hemoglobin is being broken down, certain portions of it are then being absorbed, which is what gives that melena, that dark, kind of black, tarry stool appearance. A bowel obstruction is just that. When you obstruct, right, the bowel, right, there are certain areas it can be, right? Literally, just think of like a cork in a dam or a plug in a dam, right? There is something actually obstructing the flow of stool through the intestines, right? Whether you have, bowel paresis or, kind of paralysis of the bowel itself, or if there's some sort of trauma, some large tumor, or if somebody just has significant constipation. Right? As I mentioned, the purpose of the large intestine is to absorb water. And as I mentioned, if there's too much water absorbed, that's going to cause constipation, which is going to slow the stool moving through the GI tract. Well, if it slows the stool moving through the GI tract, specifically the large intestine, then it's going to move that much more slowly and that much more water is going to be absorbed. So it just makes constipation that much worse, which you can then foresee the cycle. So if that occurs and the person is obstructed is not constipation, right? Is obstruction, but that stool is there. It is obstructing the intestine. It needs to be removed, right? There needs to be some way to eliminate that actual obstruction, right? Just like if there's a car accident in the middle of Interstate 81, right? Those cars have to be removed, right? The traffic isn't moving slowly. It's not constipated. It's not congested. It's an accident, and those cars have to be removed. That makes sense. So here, intestinal polyps, again, very common, right? Same idea. Polyps are just kind of benign little kind of growths on generally the inside portion they're off the inside portion of the colon. By themselves aren't problematic. Like they're benign. There are certain polyps in certain locations where they could potentially be associated with different intestinal cancers and that sort of thing. But polyps in and of themselves, they are very common and generally are not problematic. Now, UC and Crohn's, right? When we think about UC, right? This is ulcerative colitis, right? Ulcerative colitis. So when we think about ulcerative colitis, right? Excuse me. Both of which are going to be able to impact the large intestine, or both of them are going to impact the intestines, right? Now, the portions in which they can actually affect, right, with ulcerative colitis, right? Ulcerative colitis is only seen in the large colon, right? The large intestine, right? Crohn's can be seen throughout, right? Generally, Crohn's is, most commonly you see it in the small intestine, right? I believe it's the ileum. I believe is the most common portion of the GI tract. But Crohn's you can see throughout the GI tract. Right? Ulcerative colitis you see in the large colon, and it's only the one thing with ulcerative colitis, it's only the innermost lining of the intestine. Right? It's only the innermost lining. Crohn's actually impacts the entire thickness of the intestine. Right? As far as symptomology wise, I mean they can be incredibly similar, right? As far as fatigue, as far as GI distress, right? Bloating, cramping, bleeding, all those sorts of things. There's really a lot of similarity between the two, but how they actually get diagnosed, what problems actually, or what the actual problems they cause, those are quite a bit different. So from here, right, this next presentation that I'm going to get into, this is going to be dealing with kind of looking at metabolism and nutrition, right? We had talked quite a bit about the GI tract, right? Absorbing food, or first digesting the food and then absorbing the food. And I mentioned really the whole purpose to that is to make sure that we are absorbing enough nutrients so we can carry out the many thousands of chemical processes that the body needs to occur. Right. The most important one is the production of ATP, or adenosine triphosphate. Right. This next presentation, we're going to get into looking at and talking about something called oxidative phosphorylation, right? ATP production, glycolysis, all those sorts of things, because that's where we start to actually produce this, this energy that the body requires.